Well, hi there, and welcome to this, our first webinar of Memoori's 2018 Smart Building Series. And obviously, a Happy New Year to everybody out there. Best wishes for 2018. We're going to be, as always, doing a webinar every month and hopefully bringing you some really interesting smart building content over the next 12 months. So looking forward to that. Of course, as ever, we publish all of this content after the webinar, so you can now find us on iTunes and also SoundCloud. If you just search for Smart Building Series, you'll find us there. And I think you can also subscribe in YouTube now. So we started a YouTube channel. We'll be posting the audio and the video there. So keep out for that. There'll be a link on our website. And we'll include not just the slides, but also some of the links to what we talk about today. So without further ado, let's get on with what we're discussing today. And we are talking about reinventing DDC in the age of data analytics. So as computing in edge devices becomes more powerful, do we need to rethink the DDC to become more data-centric? Not just able to perform analytics, but also connected to the cloud and all that without any gateway hardware. And I'm joined today by three guys who are going to help me discuss and go through that issue. So we have Jim Lee from Cimetrics, Anto Budiardjo from Anka Labs, and also Alper Üzmezler from Anka Labs. And I'm going to ask them to introduce themselves in 1 second. But before I do, we want to obviously get collaboration from everybody listening. So if you do have questions for myself or obviously the guys on this, then please type them in. If you type them in, I will get the questions here. And then once we've gone through the presentation, then we can start a discussion, and I'll put those questions to the guys in the order that I get them. So let's get going. Maybe you can start with you, Anto. Do you want to introduce yourself?
Yeah, I'm Anto Budiardjo. I'm CEO of Anka Labs. I've been in the BAS industry for about 30 years. Started in the UK with a product back in the late 80s, and have seen the evolution of the industry over those years. Has been quite interesting. So glad to be here.
Hi, my name is Jim Lee. I'm president of Cimetrics. I've been in the industry also for about 30 years. Cimetrics is now 29 years old. We are primarily involved with Backnet, creating the underlying protocol stacks and tools to help the industry communicate using open systems. And in 1998, we started to get into the building analytics business, which now accounts for most of our revenue.
Hello, my name is Alper Üzmezler. I'm the CTO of Anka Labs. I've been in the industry for 17 years, so I'm considered a newbie. And yeah.
Okay, so
if my maths is right, that's what, 77 years of experience.
There you go.
So yeah, I think we're well qualified to answer questions.
Okay, so we are actually here together, the three of us. We happen to be at the AHR Expo in Chicago, where it's snowing and very cold. But before we do that, just sort of give a brief agenda of what we're going to talk about in the next hour. I'll make some comments about AHR. Jim Lee will make some comments about the New Deal, which is an initiative that we'll explain. I'll talk a little bit of sort of a high-level picture on this concept of the edge. And Alper will talk about really how we think the DDC should be reimagined. And this should leave quite a bit of time for Q&A that hopefully we'll get a number of questions. So AHR, for those who are not aware of the event, it's the largest heating and refrigeration trade show convention. This year, the organizers claim 70,000 visitors, which is pretty large. It's packed. Most of the products on the floor were obviously mechanical products, so it's not directly relevant to our sort of focus on automation and systems. But there's a material and significant amount of BAS on the floor, as well as in a lot of the education programs. The education program at the AHR has actually evolved over the past few years to be quite solid. Quite a lot of a really interesting discussion. And if I were to sum up a sort of a takeaway from this year's show, is really a discussion about data and the sort of concept that data is the new gold. Data is more valuable than the hardware that exists, that creates the data. So that's actually a very interesting way of actually looking at it. And it's from a building automation perspective, that's really good because it really focuses the attention on what we are all doing in the BAS space. So that's my little sort of feedback on AHR. One of the things that happened at AHR this year is the announcement and launch of a thing called a New Deal. And I'm going to let Jim Lee explain what it's all about.
Great. Thanks very much, Anto. So the New Deal, if you really look at our industry and where we've been over the past 30 years in direct digital controls, big data, building energy management systems, analytics, one quickly realizes that we're in the infancy of this industry. One of the problems we find is that there's very slow adoption of these technologies. There are marvelous technologies out there with very sound value propositions, and the adoption is still relatively low. And there are many people in the industry, many consulting groups, many talking heads trying to analyze why the adoption of these technologies is so slow when, in fact, the economics are tremendously compelling. And what we find is that if we go back to first principles and imagine how buildings are actually built, what's the business process involved? For instance, the Construction Specification Institute standards, how buildings are bid, what the interests of those parties are. We get into a whole realm of business models and an interesting area that technologists don't often interface with or meet with. And we believe that those fundamental problems about disconnects between the groups that build buildings and the groups that operate buildings, both financially and contractually, have contributed to slow adoption of these technologies. So fundamentally, a number of us were talking over the last few years, and we couldn't find a forum in the industry where we could have this cross dialogue about business issues. There were plenty of forums to talk about technology issues, but we really couldn't find a great place to talk about business issues. So we started one, and it's called a New Deal. And the idea is to generate a new deal in the business understanding between owners and vendors and service suppliers in the buildings industry. So if you look at that, we've decided to frame the major tenets of the New Deal in terms of open standards, digital twins, and fundamentally service transparency, which we think is the most important. So just taking those things in sequence, if you look at open standards, I've spent most of my career on open standards in the industry. And like the internet, open standards are really a way to break existing business models, but also create a normalization of data. So if we can all call a voltage, a temperature, a pressure, an amp the same way and understand the same default behaviors of systems, then we can all liberate value from the data that's out there. So the open standards movement is broad and has many powerful attributes. The next thing is a digital twin, which is that if I really want to analyze that data, I could just statistically analyze it, take large amounts of big data and use data mining tools to go through it. But that's a little silly because we actually already have a clear perspective of what these control systems do. And that allows us to build a physical model model of the physics, if you will, of that system. And if we build that in the cloud, we can then take real-time data that we collect from sensors and actuators and from the Internet of Things at large, and bounce that against that digital model in a building emulation process, and therefore use that physical knowledge and how the equipment operates unilaterally, as well as how that equipment behaves in a system. So systemic behavior. We can analyze that and do interesting things like fault detection, diagnostics, etc. But now getting to the third tenet, service transparency. If you look at Uber, we've all taken cabs, and I think many people have made the transition to services like Uber or Lyft. But it's really knowing when the vehicle is going to arrive, knowing the route you're going to take. These are things that really change the game in its entirety. If you look at the building automation business and look at things like variable air volume boxes or unitary control units, there's no possible way that building owners today have transparency into whether those systems are working or not. They're 100% reliant on vendors who often don't have the tools or the capability to even understand the systems themselves. So by using digital technology, analytics, to analyze that data, we can change the entire game and effectively Uberize the building by providing not just the building owner, but all of those constituents with the information they need to change the game. And it's this transparency that really allows the New Deal to flourish. Now, a few more comments here. The industry is at a tipping point because the business models of the industry have been primarily predicated on hardware sales. And even if we look at the system business, it's largely been a hardware paradigm. That hardware has commoditized. And within 5 years or so, the industry has to make a transition to where there are funding sources for system integration and IT-like problems. That's the world we're heading into. So as we synchro-mesh the New Deal, open standards, digital twin, and service transparency, we're going to arrive at these new models, whether we like it or not. Next slide, please. So a number of us have been working on this for some time. I invited my competitors, my friends in the industry to get involved. We all got together under the auspices of the Continental Automated Buildings Association and just produced a beautiful white paper, which is now available, which codifies a number of these ideas and lays them out. So I would encourage you to pull up that white paper and see what it's about. Next slide. And finally, for those of you who have opinions, we have started an open blog, which we call the newdeal.blog. And we have a series of articles from many people and many different perspectives in the industry on analytics, on business models, on transparency. And we would welcome submissions to that blog. And one can contact Anto Budiardjo regarding that. There are links on the blog to that. I think that concludes my remarks. Thank you.
And we'll put some links to those things on the show notes as well.
Great.
Thanks so much.
So moving on to how this happens, and one of the words that gets talked about a lot these days in the context of where BAS is headed is the edge. So a lot of people say, what is the edge? I mean, this is kind of a network term. So I had an opportunity of presenting some slides on Monday at a session that was led by Ken Sinclair from Automated Buildings, automatedbuildings.com. And this is what the slides were. And I sort of want to start going back to the 1980s. These are kind of the albums we were listening to on vinyl. Those were the good old days, as it were. But if you think about the sort of architecture, the sort of network architecture that we had back then in that era in the 1980s, they kind of typically look like this. They were very complicated. There were different types of servers in different areas in your office, in different other sort of circumstances. There were different network protocols, X25. There were different network connectors like Token Ring, for example, that don't exist anymore. So the point here is that these were really quite complex and in many ways convoluted network architectures. And this was the days of very simplified personal computers. The Commodore PET at the top there was the very first computer that I bought in 1980. It was great. It was fun. And that was a great start. And the point here is that the typical architecture that we today still use for BAS control for DDCs is actually not too different from what you're seeing here, right? And that's because the DDC evolved through the 80s and the early 90s, becoming more networked and starting to provide value. Right, so that's great. That's brought us to where we are now. But let's look at how we live today in comparison to how we lived back in the 80s. We don't, most of us anyway, don't listen to albums on certainly not on vinyls. And today we do everything pretty much online. Right? We use Spotify, Pandora, iTunes, and other streaming services that's available around the world. And when you look at the network architecture of today, essentially you have this three-level architecture. You have these devices that we have on our desks or on our laps or in our pockets that all essentially talk to the network. And the network could be all sorts of different networks, whether it's 4G, LTE, Wi-Fi connected Ethernet, or satellite even. It really doesn't matter, right? The point is that the network is there to connect these devices to the cloud, right? And it's in the cloud that you have everything from your email, your storage, for example, Dropbox, and obviously our social life is on Facebook these days, right? And essentially these devices at the bottom is the edge of this particular network, right? So we as human beings, as consumers, we are the edge in the context of how we use technology today, okay? And the interesting thing is that the edge, there's a lot of discussion about whether it's better to be in the cloud or on the edge. My view is that you can't make that distinction because our life is actually spread between the edge and the cloud, right? If you pull up your smartphone, you'll probably have 100 or 200 or several hundred pictures that you've taken over the past months and years on the phone, and yet thousands more may actually exist on the cloud, right? And the two sort of work hand in hand, given the resource availabilities and the sort of type of usage that you actually need, right? So that's kind of how we've evolved, right? And so the point here is that why should BAS be any different? And our sort of philosophy is that it shouldn't, right? DDCs that typically have the sort of typical architecture before of what I was showing you in the 80s really should exist as edge devices on a network similar to the network we use in our daily lives, right? So whether it's a controller or a VAV or thermostats or a panel or a bigger programmable controller, those should really just connect to the network, and it really doesn't matter what that network is. I mean, obviously for a particular project it matters, it needs to work, but from a conceptual, from an architectural perspective, it doesn't matter. And they all really will connect to services and applications in the cloud. And users will typically be interfacing or interacting using browsers to these services, right? So these edge devices are the devices that will perform controls, as in DDC controls. They'll perform analytics, either on the edge or provide data for analytics to be in the cloud, and they'll also perform any applications, obviously, that's necessary to make the system work. So that's really how we see what the edge is, and this was actually a very vibrant session on Monday, a lot of discussion about this, and obviously other speakers had comments that were, pretty much in line with where we headed. So that's what the edge is, as the way we see it. I'd like to move on now to how we think we can reimagine the DDC. And I'm going to hand over to Alper for this.
Hello. Within the Anka Labs, what we are doing is we are creating an Anka device operating system. And the device operating system consists of multiple open source technologies, and I would like to explain you those. One of the applications that we are using is Sedona framework. 3D actually made this open source, and after they tackled the gateway problem, and in order to make the DDC systems compatible and portable between manufacturers, they wrote a Sedona framework, and they actually hired someone from an industrial design, and where they had actually tackled the problem of compatibility of applications in between manufacturers. So we are utilizing that. It's well written, and it is proven technology within the industry, used around 7 different manufacturers throughout the world. Maybe it's a little more than that. The next technology we are using is Project Haystack. It's open source taxonomy standardization. It has multiple parts within the application stack. One of them is a file standard format called Zinc. Within the Zinc file, we design the tags for normalizing the data wherever it is coming from. We are utilizing this system within the architecture for abstracting the data that comes from the controller devices. Within the Project Haystack, it not only has a taxonomy, it has a standardization for REST API operations, REST API calls, and it is within the Project Haystack. Those are called ops. By doing this, we are basically abstracting the data for the control logic within the application. Right on top of that, we have SkySpark for doing data analytics, and then we have Visualitic, which gets the data from Project Haystack standard model as well for visualization. Within the application, we have a reference model controllers. We have analytics engine, and we are also working on an app store where we can actually share apps and configurations. The current system architecture is basically consists of microcontrollers all the way to the edge. Then we have a gateway devices. These are microprocessors, and they have some memory and disk space to store historical data, trends, and alarms. These are usually installed on for larger buildings. You would have either per floor one of these gateways, and then those gets connected through Ethernet to a supervisory level application. Within our model, on the edge device, we do have a microprocessors within the edge devices, and the whole stack lives within every device. This simplifies, it basically gets our architecture level in a single level where we can send data in between devices easily, and we can also send data northbound to cloud or internal cloud services. And all the applications live within the edge devices. Also, there will be a transition time for us to go into these buildings is for retrofits. So an edge device can replace an air handling unit controller with a microcontroller, from a microcontroller to a microprocessor, where we can link the VAVs that it is serving through means of other protocols like Backnet. This would give us more trending capability, analytics capability, and also we could correct the behavior of the air handling unit runtime or others. You could also use these devices just as gateways as well. It doesn't stop you from doing that. The feature of fog. Fog is basically putting the compute power all the way to the edge. Within the next 5 to 10 years, we will see a lot of sensors, a lot of devices that have compute capability right at the edge. And we are basically thinking about how we would pass the data between them and how we would execute those compute processes in the edge. Actually, our stack is capable of enabling the fog in the future by utilizing other wireless technologies.
So another way to look at this sort of progression of how DDC is evolving into what we at the Anka Labs are calling edge analytics controllers is the economics of it. But as Jim Lee said earlier, it's not just about technology; it's about the business side of it. How can we actually make this whole process of delivering data and the things that needs to be done to deliver data much more efficient for all parties? And one of the ways of looking at that is looking at the labor cost, and specifically in this case, we're looking at the engineering cost, the labor engineering cost for a typical building automation system that goes all the way up to the cloud. And today, essentially, this list of 10 things are the sort of a list of the things that somebody has to do at some point to engineer or to configure, to install the system. So number one is somebody has to set up the DDC and serial network, and then they have to program it, and then the same goes to the gateway, and then there may be a configuration and activity to install any supervisory PC or database on site, and then tagging needs to be done, and then it all goes up to the cloud where analytics is done, right? That's a lot of steps, and it's typically done by different people, which provides its own challenges. And it's also another level of challenge is that these steps are typically done using different tools, because a lot of the products or services that's being used are coming from different vendors, right? So our view of how we should really be thinking about simplifying this whole process, as Alper had mentioned, sort of reduces this pretty significantly. So it reduces it down to essentially 3 steps to connect the sort of new class of DDC that we call EAC to the internet, obviously using whatever security protocol and criteria that's necessary. That's critical and that's very important. The use of metadata and tags allows fundamentally a different way of configuring the device itself, because it actually uses tagging and uses metadata to configure the logic, to configure the trending, to configure any analytics and even any visualization that needs to happen, right? So that happens mostly automatically. I don't think it can happen totally automatically yet, and it just leaves sort of step number 3, which is to adjust and sort of customize whatever's need to be done. And sort of think about this as the progress that we have in connecting peripherals to our laptops and our PCs. 10, 20 years ago, it was very difficult to connect a printer because you have to have drivers and all that kind of stuff. And today you plug in a USB and somehow magically you print, right? So all of the configuration is done automatically. And that's done using a similar process, obviously not the same as BAS, but the USB connection and the software on both the printer and the or the peripheral and the computing device kind of knows what it's all about and kind of configures itself, and then we tweak it to our needs. And the last point about this is that all these 3 steps, not a lot of steps in the first place, can be done and should be done using an internet browser. So it simplifies not only the actual workload, but the tools that's needed. And doing things using internet browsers, obviously not new to us as people, because that's what we do every day. And so that's how we see the progression of the DDC. Okay, and that's really the kind of the conclusion of our prepared remarks. Hand it over back to Jim, and hopefully we can have some discussion and some Q&A. Over to you, Jim.
Yeah, absolutely. Please, anybody, if you've got any questions for these guys, then now's the time. We've got plenty of time to have a chat, and it's not often you get the opportunity to ask people with 77 years of experience in the industry. So take the opportunity while you have it. Maybe perhaps we can start by going back to the stack slide. I think that's very interesting. That shows. Yeah, here. I mean, maybe you could, talk a little bit more about this. I mean, my understanding is that this is an operating system, right? That you want to install on edge devices. Perhaps give us a scenario of like a specific device that someone might install this on. Who are they? How would it work?
I probably can give two examples. One is just a programmable controller, right? You can buy today a programmable DDC that from a manufacturer that typically have a proprietary logic engine and logic programming sort of tool, right? So that's with what we see is that if that same device were to use Anka, which is what we're calling this product, they will obviously, the user of such a device would obviously need to do the same thing. They would need to program it, but in this case, they'll be programming it using Sedona. So the first thing is Sedona then becomes a tool that is common to any product that uses Anka, as well as products that actually uses just Sedona itself. But because Sedona is tightly integrated with Project Haystack, you then get the enormous benefit of the tagging and the metadata. That could be a separate webinar, because it would probably take more than just a couple of minutes to explain how that works. But it's really quite transformational in terms of how you can use tagging and metadata to actually program, as opposed to hardwiring any logic to a specific I/O. We actually sort of abstract out the hardware. So then that particular user may also need to do some analytics, maybe just a little bit of analytics on that particular application that he is installing the controller in. And that then becomes the use of the SkySpark component of the stack that's already there. So you just kind of switch it on. You kind of say, I want to analyze this particular point or this particular data stream or those particular data streams, and then it will just go and analyze it. And similar with the visualytics component would actually then provide a picture of whatever it is that you're doing. So on a programmable basis, that's kind of how you would use it. Another good example is the installation of a VAV. Right? So a VAV in the future we see as also including this stack, right? And obviously a VAV, there's less programming involved, because the logic of a VAV is pretty narrowly sort of defined. And in this case, there may be just different parameters, maybe different temperature sensors that need to be consumed by the VAV. And again, the metadata takes care of all of that. And in one instance, it may actually just have one temperature sensor coming to the VAV or a similar device. In another instance, it may have two, or one or two or three, whatever it is. And one of the magic of the data model and the way we've actually implemented is that the logic that's driving this within the stack can actually self-regulate its logic depending on the input and output that's available on the device itself. Right. So that's the part that actually simplifies the process of installing a device.
Mm-hmm.
Either of you want to add to that? Does that answer your question, Jim?
Yeah, absolutely. And we have done some previous webinars on Project Haystack. So if people want to learn about that, then they can go back and look at that. As Anto said, it's very interesting semantic data model and pretty powerful and again open source. So the more people that can add tagging data information to that, then the more powerful it becomes. I noticed as well that it's built on, you say here, secure Linux operating system. So it's sort of open source from the ground up, right? You've built this stack using open standards. Is that right?
It's I would say it's predominantly open source. It's not open source. It's not all open source.
Okay.
One piece there, the SkySpark component is obviously not open source, and the data engine which we had to provide is not necessarily open source. But a lot of the really key components such as Sedona and Haystack and others that we don't even list there, obviously Linux is one of them, are open source. And this is, I think, a typical thing that you see in applications or in systems today. If you actually look at even Windows or a Mac or applications that run on those kind of platforms as well as apps on your phone, they would include a significant amount of open source, and so that's how things get made these days.
Right, absolutely. Build on these common standards, right? And I noticed.
I want to just sort of just make one point about Backnet. I mean, Backnet is a key component of building automation system, and we clearly need have Backnet as a key part of how the stack will work. Jim, I don't know, you know more about Backnet than anybody else.
Sure. The only comment I'd like to make is we're trying to foster a close collaboration between the Backnet world, the Backnet committee, and the Haystack effort. So we're very much hoping to see some good cooperation come out of that on the tagging side.
Right, absolutely. The question here, what revision of Backnet is being used in the Anka DOS?
What revision?
Well, I think they mean what version.
Well, I mean, I think that Backnet is a continuously evolving technology. So there's a standing standards project committee within ASHRAE. So I would frame it as Backnet as a whole is being updated, and there are different addenda being added. But I'd have to let you guys speak to what's in the stack here.
Well, I mean, from a product strategy perspective, my answer will be that we have to install the whatever's currently being done, the sort of the current release or the current available standard. But more importantly, I think the future of it, there's a lot of work, as Jim mentioned, going on in the Backnet committee, especially bringing in sort of IT perspective and security perspective. I think a lot of people know that there's some challenges there that needs to be done, and that's being addressed by the Backnet community, let's say. And part of what we're doing with Anka DOS is to make sure that we stay in front of all of that work. You want to add anything, Alper?
Yeah, so as Jim said, the Backnet will be utilizing the Haystack tags, and we will be mapping the Backnet to the project Haystack, and that way getting the data into Sedona or to SkySpark would be a seamless process.
And just one point, just to clarify this stack and this this product, as it was, Anka does. This is an ongoing. We've essentially only just started this, started to roll this out.
Sure.
We've been working on this for quite some time. One of the things that happened this week also is that we actually released the alpha test version of this stack to a closed, small and closed number of people to test it. That's kind of what we need to do, and we'll go through a beta test, and then we'll release it probably sort of mid-year.
Okay.
So it's still, and my last comment on this is that we obviously would welcome any of the people viewing this webinar to actually reach out to us with any specific questions or any specific suggestions, because we want this to be, although it's our obviously our product and our stack, we want this to be something that a lot of other people contribute to and use, and there's other sort of ways that people can be involved with this the development of the stack and the rollout of the stack.
Sure, because I see here that there will be an application stores and other licensed technologies there, so you'll be able to add to this and produce customized things, applications. And again, I guess if people want to beta test this, it's something that they can contact you about if they're interested when you're ready for that.
Absolutely.
Good.
Absolutely.
Got a bunch of questions coming, so I'll get on and ask you guys what's come in. Someone here asking, how might IBM, Google, Microsoft, and large consultancy and integration firms benefit from an open, transparent DDC ecology? If it is in their interests, would they be best partners for selling the vision to building owners at the C level? And is it time to start selling DDC and relevant services to the C level, specifically CIO? Any thoughts on that, guys?
Yeah, absolutely. I think that the conversation needs to move to the C level, especially in some of these fundamental business processes like building a new building. The problem that you've run into historically is that people have been myopically focused on energy value propositions. And if you look at most large organizations in the world, energy is 1% of what they do. So if we can save 20% of 1%, we've immediately put ourselves down into irrelevancy. When the larger story is not just an energy-only story. And I think people are waking up to that. There's a very compelling energy story, by the way, for what we do. But really raising things up so that we can explore some of these other value propositions, like productivity, comfort, etc. I think it's very important. And I do believe that some of these large organizations can change that story. But it's actually not necessarily the tech companies that need to change the story. It's more consulting companies, people that would be selling business process reengineering. So I would look at that class of companies, the large consulting companies, who could, by changing the way accounting is done, changing the way procurement especially is done. Today we have a system where almost everything is competitively bid. And in the day when we were working with commodity items, that made a lot of sense. Now we're trying to competitively bid professional services. And I'd ask anyone out on the call, are you going to go low bid your brain surgeon? And the answer is no. So if you were to replumb the IT system in your entire campus or your entire enterprise, how much budget would be allotted to the IT department to do that? The budget allotted in the building automation world is zero. There is no line item for any of this technology in any of the business process that's out there today. So as our business transmutes into IT, we face the same problems. without any of the resource to fix it. All we have is a race to the bottom, low bid process, which basically solves no one's problems. It's a lose-lose. So I think that will be, if you look at business process reengineering as the change agent, rather than the pixie dust from the usual IT suspects, I think that's where it's at.
And to tie that into the technology part of it, right, and the rationale for creating this stack, is Jim is absolutely correct. All of the discussion and the evolution, especially at the C-suite level, executive level, needs to be about business and value and all that kind of stuff. And that obviously is why we did the New Deal. That's the whole deal about the New Deal. But when you think about it that way, then there has to be some stability and some standards, sort of use the small s for that, in terms of how we're programming things, how we're buying things, how the sort of stack, the software stack that exists in the systems, especially in the DDC, in the edge devices, right? And it's kind of like if you think about the typical IT system or the typical sort of decisions that CTOs and CIOs need to make in their daily lives in sort of enterprise kind of systems, it would be chaos if there were dozens of different operating systems and dozens of different ways that you connect to the network. If there were dozens of standards, if HTML didn't exist, for example, if Windows didn't exist, if something like Word and other things didn't exist. So we have to sort of simplify that.
Yep,
right?
Absolutely. I think some excellent points there you've both made, and kind of reminded me about one of the points you made right at the start. Data is the new gold. I think obviously what you're doing here and what Jim talked about is, if we can get the data out of these systems, then it can really add value to companies and what they're doing, and we need to be able to sell these concepts to the C level. I have some technical questions here. I hope that's okay for you guys. Number one, is the product tested in by BTL? Not something I'm aware of, but do you know what that means?
Yeah.
BTL is the Backnet testing laboratories.
Okay.
Started by the Backnet Manufacturers Association, which I founded many years ago, which is now called Backnet International. And
It's a good question.
It's a good question. The BTL is a compliance testing organization which tests products for compliance to the Backnet standard. In addition to that, Backnet testing exists in interoperability workshops where different companies come together and test their products collaboratively. So we're testing for both compliance through the BTL, as well as interoperability through these interoperability bake-offs. And that's what Backnet testing is all about. And as Backnet is only one component of this Anka stack, I would say that it usually is not the purview of the software supplier to do those tests, but the final manufacturer typically submits their products to those kinds of things. Mm-hmm. So typically, when Cimetrics sells a Backnet stack, we've had many customers over the years run that stack through compliance testing, but we ourselves don't test the stack for compliance. It's tested in the final products. Does that make sense?
Yeah, absolutely.
Just to raise one point that I think Jim mentioned is that the intent of AnkaDOS, the intent of this stack, is for this to be licensed to be used by many different manufacturers, vendors of either control systems or package mechanical systems, right? So I'm not sure we made that clear earlier.
Okay. Yeah. No. Absolutely. Thanks. Next question, maybe one for Alper here. What are the minimum requirements of an appropriate device, i.e. CPU, to run AnkaDOS?
Currently, we have prototype as a reference model devices. It has 1 gigahertz ARM processor with 512 gram is sufficient. So any of the new modern makers devices are sufficient to run this. So it requires a microprocessor, not a microcontroller, for it to run.
Okay, great. Maybe we could go forward a couple of slides to more of the system diagram. Yeah, here we go. Question here. Somebody's saying that security is a big concern for them. Maybe you guys could talk a little bit to how your system operates in terms of have you baked security into it, and if so, how do you envisage that working?
Security is a concern, and we're tackling it in starting from the operating system and keeping the application only in a readable only area. Other than that, all the communication that goes northbound is encrypted. That is another security feature that we added. The last security feature that we're implementing is over-the-air updates with an encrypted keychain, and the applications that will run within the Anka DOS will have to have keys for it to run, so that we are implementing those features as a way to keep data and also applications that are running on the system being protected.
Okay, yep. Another question here, Anka DOS system for Project Haystack. Can we interchange components below it, for example, data analytics, facilities connects? So I guess the question is how flexible, the stack.
Well, the flexibility is here. The flexibility is in the App Store component part, right? So we've made the decision that the core stack is what you see here, because those are the things that are needed, and those are the products and the technologies that we know work really well, right? But if somebody and by creating the app framework, then other vendors of other applications or core technologies such as analytics can create an application that will plug into Anka DOS that will work in many ways the same way as something like SkySpark, right? So it'll be at an equivalent level. So that's exactly why we've done this. So we're starting from a good starting point, but we're making it flexible so other people can develop their own applications that can go into the stack.
Yeah, absolutely. There's a question here as well. What is the Anka optimizer at the bottom of the app framework? What is it that's being optimized?
What we are thinking on that is that there is real-time data that we control by DDC, and we are doing analytics in SkySpark. There will be applications in future that will automatically consume the analytics results and optimize. And those app frameworks will be third party, or we are looking into partnering up with other companies to come up with strategies to close the loop between control and analytics.
I think that the point there is that by creating an app store, we will automatically create an ecosystem of app developers, and if we do this well, then all sorts of innovation, all sorts of technology can be created by people all over the world to actually plug into this and provide a channel for them to expose and implement and put to market, bring to market their solutions that can go essentially to the global market. So,
because it looks like, I mean, from what my limited technological eyes, that it's very customizable. So I mean, we talked a lot about HVAC, BA, building automation, but I could imagine this could be used in other areas of building controls as well.
Yep.
Yeah, and maybe we could just go onto the systems diagram again. What interested me, and I know we talked about this before, about this sort of the old way of doing things through this gateway system. I mean, what we're talking about here is essentially getting rid of that, right? It's quite a change we're talking about from the old architecture.
Yeah, so it's getting rid of it, and it's not getting rid of it, right? Let me explain.
Yeah.
It's getting rid of it from the point of view of a piece of hardware, right? And a piece of hardware involves not just purchasing it, but installing it, maintaining it over the years, updating, and all that kind of stuff.
Yeah.
But in many ways, a lot of the applications, a lot of gateways and supervisory sort of devices that exist today actually does something that will continue to be needed, right? And so our sort of way of looking at it is that's where apps come in. So whatever was needed to happen in gateways and any kind of other boxes basically gets turned into software that will be installed in one or more of these devices.
Yeah. So yeah, it's just changing, I guess, where the intelligence in the system kind of lies. Of course, we're talking here about the edge. We're moving intelligence to the edge.
And moving it from hardware to software, which goes to how things are happening in the rest of the IT universe.
Yeah, absolutely. Well, we're coming towards the end now, guys. So if anyone has any final questions for the panel here, then please put them in now. I was going to ask Jim, what's going to be going up on the New Deal blog? Is there what kind of articles can we expect?
Well, we have a series of articles already written. Some about interoperability, the digital twin, business models. So there's quite a collection of great articles there already. An excellent one that Therese Sullivan just published. But Anto's just put it up on the screen.
Mm-hmm.
So they're a great series of articles. We intend to add links to the new CABA white paper. And coming soon, there'll be a series of articles discussing procurement in the industry and what some of the problems are and what some of the resolutions to those problems are.
Right. I mean, that could be a whole new webinar, couldn't it? I know we've talked about that before. And as you said, I think at the start, that's something that we could, as an industry, do a much better job of bringing that together. The whole how equipment is bought on a contractual level and etc.
But the tone of all of the articles, and this is part of the kind of editorial process that we go through, the tone of it has to be and will continue to be a focus on business issues and targeted at executives and C-levels. So you're not going to see an article here discussing the depth of some technology comparison or whatever. That's not the place for this. It's very much on the business side and the value proposition side of things.
Great. Well, any final thoughts from you guys before we wrap this up?
I just wanted to thank you for having us on, and we look forward to continuing the dialogue. And once again, if anyone has perspectives, primarily on the business side, that they'd like to contribute, we'd welcome them as contributors on the New Deal.
Great, and I will. I'll make sure we put up links to the blog and also the CABA white paper you mentioned as well.
One last thing about how we're taking Anka DOS to market. Obviously, our target is to put these into a lot of OEM devices, but one of the things that we are going to do to get this out there is we will create a community edition of Anka DOS that once it's all tested and everything else, will be available for free download for anybody to use on very, very low cost BeagleBone Raspberry Pi kind of class device. So look out for that. That'll be a really good way of people to start to understand what this is all about and start to prepare for their future in the data-centric world of BAS.
Yeah, absolutely. Where can they go for more information? Do you guys have a website?
Yeah, there's ankalabs.com. Right now, there's not much on it because we're focused on, obviously focused on the technology work, but that'll be the where everything happens.
Great. Okay. So again, I'll put a link to that. Yeah. Well, look, just reminds me to say thanks very much. Really appreciate the three of you taking the time. And I hope you enjoy the rest of AHR. How much is left now?
Just today.
Okay. Well, good luck. Hope it all goes well. And thanks to everyone.
Thank you, Jim.
Thanks, Jim. Thank you for having us.
Thanks for everyone for listening. Again, we've recorded this, so I'll be posting the audio on SoundCloud. It'll also be available on iTunes and YouTube as well. So if anyone wants to listen again, you can find us there. Thanks again, and look forward to seeing you next month. Bye-bye.
Bye-bye.